Okay, so on your warm-up, you're asked to sketch. The reason we want to know how to sketch is sometimes that's all we need to answer a question, right? I didn't even pose the question. I just asked you to notice something. So let's see if we can notice something. So for each of these, we're going to use Desmos to help us graph these. And that looks like this, right? You just plug it in to Desmos, right? And the cool thing about Desmos is it's made for math students. It knows that you want certain things. You look, there's already a point up here at your vertex, right? You click on it, it tells you the value. There's already a point right here at your y-intercept. You click on it, it tells you the value, right? It kind of knows what a math student's looking for. So it tries to make it easy for you to find. You could also trace along to find any point you want, right? Found a point right there, 2, 6, right? So Desmos is really useful, so is your graphing calculator. Okay, so for each of these, let me add these real quick so we can talk about them. You would just add your vertex. This is what a sketch looks like, right? You add a vertex, add a line of symmetry, axis of symmetry, x equals 1, right? And then you sketch from there. You could also, since we know our y-intercept, we could add that as well, 0, 6, right? And we do that for each one, okay? I'm going to add those real quick so then we can talk about them. At the bottom, asked us, what do we notice about the relationship between the vertex, that highest or lowest point, and our a value, right? Our a value in each situation, and then the highest or lowest point, that vertex value. So, do we notice anything? What do we think? There's a takeaway here. Here I had -2. There's my highest point. Here I had 1. Here's my lowest point. Here I had -3. There's my highest point. Here I had 3. There's my lowest point. What do you think?
If you invert the parabola, it's going to have a positive highest point.
Well, kinda. What if I had this, though? That could happen. But in this situation, that is true. But it's not a rule or a law. Yeah?
All of the negatives are down,
Yep.
and then the positives are going up.
Yeah, exactly. So if you have a negative, and we knew this already a little bit, right? But if you have a negative, you flip down, and you have a highest point. If you have a positive, you don't flip, and you have a lowest point, right? So we're going to talk about those, but let's write down that takeaway. Talk about those highest and lowest points today, okay? So if your A is negative, your parabola has a highest point, and we call that a max. If your A is positive, your parabola has a lowest point, and that's called a min. Okay? So in each of those situations up top, before you even graph them, with that knowledge, you could know what to expect. Am I going to have a max or a min, right? And we, a lot of times, have a graph, so it's super easy to see, hey, does that have a high point or a low point? But sometimes we don't. So recognizing that the a value tells you that is useful, right? Okay, so let's talk about that highest and lowest point. Let's look at these graphs again. Which part of the vertex determines if it's highest or low? Or how high it is or how low it is?
The y.
The y, right? For instance, this one and this one. Would we all agree that that's higher than that? Yeah. How do we know? 8 is higher than 3. So what really matters here when we're talking about highest or lowest point? the y value of our vertex. That's our max and our min, right? That's what matters. So maximum and minimum values are the y value of your vertex. Okay? You either have a reflection, meaning A is negative, and it'll look like this, which is gives you a max, or no reflection, meaning A is positive, and it gives you a normal parabola, and that gives you a min. So that's our first takeaway. A is negative, I got a max. A is positive, I got a min. Okay? And the min, the value you're looking for, is that y value of your vertex. Okay? So on a graph, like in our warm-up, those were easy to see. It's like, oh, the highest point is 8. Oh, the highest point is 3. Oh, the lowest point is -10, right? But what about when we have equations and we don't have a graph and we have to find them? So we're going to find them a couple different ways. We're going to find them from vertex form. We're going to find them in standard form. Okay? So that's what we're going to do next. I'll give you a second to write that down. All right, so what's our agenda here? Let me write this at the top. We are finding our max or min from an equation. And in order to do that, doesn't matter what the equation is, you have a couple steps. Step 1 is decide max or min, right? You have to decide, do I have a max or a min? Because it's going to be one or the other. And what do we say tells us that? The A value, right? So look at A value. And step 2 is to find that value. And where do we find that value? No, I'm saying we decided we have a max, for instance. Now we want to find the max value. Where do we find that value? It's in the vertex. So we need to find the vertex. And we pull the y value. All right? So those are our steps. Just 2 basic steps, right? So we're going to do this in a couple different forms. The first form is that vertex form, which is useful because this one, everything's in the form. A times x minus h squared plus k, right? It's all there, right? So our first step, right? First thing we need to do is decide if we have a max or a min. And where do we look? A value. So our A in this case is what? -2, right? So is that negative or positive? -2 is negative. A is less than 0, so we have a max. Right? Because we know the graph will look like this if it's negative, and that's a max. Right? So we've answered the first question. The next thing we need to do, right? Well, we said we needed to find the vertex. Our vertex, well, we're in vertex form, so we're in luck. What is our vertex here? -1, -4, right? We flip the x, we keep the y. -1, -4. And what was the value we said matters in the vertex in terms of our max or our min?
Y.
The y, right? So this part right here is what matters. So when you're pulling out a vertex form, you take that number and you make it negative, and you keep that number. See how it's -h and plus k. You flip that one, you keep that one.
If it's negative, do we flip it to positive?
Yep, exactly. Okay, so the y value is our max, or our max or min, in this case our max. So our answer to our first question is, we have a max of -4, right? Now, you might be thinking, what do you mean first question? That was the only question you asked us. Well, I'm going to add a question. Because why would we, yeah, great. Why do we even need to know a max or a min? What does it have to do with anything, right? Well, it has to do with our favorite old thing we love to find, which is domain and range. Is that what you're going to say? Yeah. Domain and range, right? It's going to change our range. Now, it doesn't change our domain. Well, why is that? Remember when we sketched at the beginning of this class? Well, I recommend if this part confuses you, you sketch every time, right? And you always have that power, right? Well, this thing is going to look like this, right? And it's going to have a vertex at -1, -4. Okay, that's going to help. That visual is going to help me with my domain and range. My domain for any parabola, all real numbers, right? Say again?
We put definition.
It depends how you put it. If you said x is between -infinity and +infinity. So this is true for all parabolas, right? So that's going to be easy in this unit. And then our range, well, let's think about it. This says, okay, this thing goes down forever, it goes up to -4, and then it goes down forever. So it's either going to be -4 or less than -4. So how do we write that? Y is less than or equal to -4. Okay, I'm going to give you a little cheat sheet rule here thing for your max and min. Okay? For range, that is. Range with max and min. Okay, if you have a max, it'll be y is less than or equal to a number. If you have a min, it'll be y is greater than or equal to a number. And that number, of course, is the y value of the vertex. Okay? Okay. Now, when we're working in standard form, we have a little bit more work to do to find our max or min. Okay? Find the same pieces, but it's a little bit more work. Break that off here. Okay. So let's do one with standard form. All right. So standard form, of course, is y equals ax squared plus bx plus c, right? And it's always good to just say what our a, b, and c is. We know our a is 1/2. We know our b is -2, and we know our c is -1. Now, our first thing we needed to do was decide if we have a max or a min, right? Do we have what's our a value? A equals 1/2. Is that negative or positive? Positive. A is greater than 0, so we have a min. Good. Okay, first question is answered, kind of. We know what we have. Now we have to find that value. What do we do to find our value in the last problem? Found our vertex. So find the vertex. Now in standard form, we learned how to find this yesterday, right? There's that formula, x equals negative b over 2a. Well, I'm glad we found our b and our a, right? We're going to plug those in. That's negative 2 over 2 times 1/2. That's positive 2 over 1. That's 2. So our vertex is 2 something, right? 2 something. We just don't know that y yet. If I know an x, how do I find a y? Plug it in. Very good. So I'm going to plug in. So y will equal 1/2 times 2 squared minus 2 times 2 minus 1. Now, I definitely would use my calculator to help me with this one. Don't need to do all that math every single time. Y equals, turns out to be, negative 3. Okay? So our vertex is 2, negative 3. Okay. Well, let's see here. Do we know everything we need to know? Yeah. Okay, so let's answer the question. We have a what? Min value of negative 3. Okay? And if we wanted to say our range is y must be what compared to negative 3? If it's the minimum, y, it's either that or greater than that. So greater than or equal to negative 3. And our range, our domain, of course, is all real numbers. Okay? For parabolas, unless they're weirdly restricted, yes. Okay. So there's one other thing we're going to do, right, before we go. Last class we talked about converting vertex to standard. We want to be able to convert standard to vertex as well. So we're going to kind of sneak this into this lesson. Okay? So that looks like this. All right, so we're going to go from y equals ax squared plus bx plus c, and we're trying to get to y equals a times x minus h squared plus k. Okay? So we're going from there to there this time. Okay, so what are the pieces we need, right? Well, looks like we need our a, we need our h, and we need our k. So might as well write those down. We need our a, our h, and our k. Okay, let's start with a. How do we find our a? Yep, it's already there. A is given. So a is easy. It's the same. It's right there, right? It's already given in the first equation. So our a is 2. Okay, so we got our a. How do we find our h and our k? Our h, k is what?
Vertex.
It's our vertex. So we're going to find another vertex. Okay, so we got to go back to our formula. X equals negative b over 2a. X equals negative 4 over 2 times 2. Negative 4 over 4, that's negative 1. So our vertex so far is negative 1 something. We know our x of our vertex. To find our y of our vertex, we just plug in. Okay. So y will equal 2 times negative 1 squared plus 4 times negative 1 minus 1. If I plug all that into my calculator, I get negative 3 again. There we go, negative 3. Okay, so we found our h and our k. -1, -3, right? So here we found each piece, right? The a was given here. The h and the k we got from our vertex. Okay? Now I just plug them into that equation, this vertex form, right? Y equals a times x minus h squared plus k. Well, my a was what? 2. And then I do x minus, what's my h? -1 squared. And then plus, what's my k?
Do we have to write minus negative, or are we going to do plus 1?
We're eventually going to make it +1 if you want to just do that. And then so plus my k of -3. Yeah, we do want to clean this up a little bit. This would turn out to be y equals 2 times x plus 1 squared minus 3. And there we go. We've converted to vertex form from standard form. Okay? Now there's another way to do this called completing the square that we're going to learn that you might prefer. A lot of people get confused by that and just prefer this because you can just find your pieces and plug them in. Okay? All right, to recap here. Let's recap. First, we talked about what a max and a min was. If you have a reflection, you got a max. If you have no reflection, you have a min. That's dependent on your A, right? Then we decided, okay, the y value of the vertex is what is the value, so we're always going to need to find that, whether we're in vertex form or standard form. So first we decide if we have a max or a min, then we find our vertex, we take the y value. For our range, if we have a max, y is less than or equal to that y value. If we have a min, y is greater than or equal to that y value. And if we want to convert, again, we need our A and we need our vertex, so it's very much related. We just plug them in once we find them. Okay? All right, questions? All right, do your homework.